Similarly, let us discuss another example. Here ferrous is reacting with the dichromate. Now reaction is taking place in acidic medium. Here ferrous has been oxidized to ferric. This dichromate is gaining electrons. It has been reduced to Cr3+. This is the reaction. Here the valence factor of dichromate is 6. Valence factor of Fe2+. You see, one ion is supplying one electron. One ion has lost one electron, hence ferrous has been converted to ferric. Therefore, valence factor of the ferrous is 1. Therefore, while doing the numericals, by using this valence factor, we can equate the equivalence of the ferrous with the equivalence of the dichromate. Equivalence of Fe2+ is equal to equivalence of Cr2O7 2-. This, in place of this equivalence, any suitable formula can be used. Suitable formula like weight by gram equivalent weight. This side, if you know the dichromate is in solution state, we can use this formula like that. Okay. Next, let us discuss another example. Iodine, it is reacting with the Na2S2O3. This is hypo. Here the product is Na2S4O6. This is sodium iodide. Therefore, here iodine is upon reaction with the hypo, here the sodium tetrathionate and sodium iodide are being formed. Now, what is the valence factor of the iodine? Here in this reaction, one molecule of iodine is participating. The oxidation state of each iodine atom in the reaction is 0. Therefore, total oxidation state is 0. This side, each iodine atom is exhibiting the -1 oxidation state. Therefore, total oxidation state here is -2. Therefore, one molecule is gaining 2 electrons. Therefore, valency factor of the iodine. Valence factor of iodine is number of electrons gained. Number of electrons gained by number of molecules participated. Number of molecules participated. Number of electrons gained, 2 electrons, molecule 1. So, therefore, valency factor of iodine is 2. Similarly, hypo. For hypo, see what is the change in the oxidation state of the hypo, reactant side to product side. For that purpose, we should have idea about the structure of this Na2S2O3. Based on the structure only, we can find out the change in oxidation state. I will show the structure first. This is sodium thiosulfate, this is sodium tetrathionate. Here the oxidation state of the sulfur is 0, here oxidation state of the sulfur is +4. Here oxidation state of this sulfur is +5, 0, 0, +5. Now, in this reaction, first you balance this reaction. In this reaction, total 4 sulfur atoms are participating. The oxidation state of the first sulfur is 0, next sulfur is +4. Similarly, in another molecule, 0 and +4. Total oxidation state +8. This side 4 sulfur atoms are present. First sulfur +5, second sulfur 0, third sulfur 0, fourth sulfur plus 5. Here total plus 10. The difference is 2 units. This difference is 2. That means 2 thiosulfate molecules upon participation have released 2 electrons. Therefore, valency factor of the thiosulfate. Valence factor of Na2S2O3. Number of electrons lost by number of molecules. Number of electrons by number of molecules. Number of electrons 2, number of molecules 2, therefore 1. Valence factor of the hypo. Therefore, whenever if iodine and hypo react with each other, you remember the valence factor of the iodine and hypo, then simplification becomes very easy. Next, another well-known redox reaction is reaction between the I minus and CuSO4. In this reaction, Cu2I2 will be formed. Next, Cu2I2. Next, I2. Next, sulfate. In this reaction, this is also well-known redox reaction and very important for numerical calculations. Therefore, first let us discuss the calculation of valence factor of the copper and iodide. Here, see, for iodide, we will take the iodide in the form of potassium iodide or so. Therefore, in this case, first if you balance, we can balance it. Otherwise, without the need of balancing, directly we can proceed. So, valence factor of iodide. Valence general formula is number of electrons by number of molecules. Number of electrons lost by number of molecules. Number of molecules. Here, number of electrons lost. One iodide is losing 1 electron. Number of molecules, so 1. So, for potassium iodide or iodide, valence factor is 1. Next, for copper. For copper, we have to balance these copper atoms first. Here, on the reactant side, we have 2 copper atoms. Each copper is in +2 oxidation state. This side, the 2 copper atoms, they came here. The oxidation state of the each copper is +1. Therefore, total oxidation state here is +4. Here, total oxidation state is +2. So, difference is 2 units. That means this copper sulfate is gaining 2 electrons. So, how many molecules are gaining 2 electrons? 2 molecules. Therefore, valency factor. Valency factor of copper sulfate. Number of electrons lost. Therefore, here gaining. Therefore, number of electrons gain by number of electrons, number of molecules. Number of molecules. Number of electrons gained. How many electrons? 2. Number of molecules 2. So, therefore 1. Therefore 1. So, for copper sulfate, valence factor is 1. Okay, sir. So, total ఎంత వచ్చింది సార్ రికార్డింగ్? 1.5 hour వచ్చింది. 1.5 hour.
15 minutes
ఎడిటింగ్తో పోతుంది. కంప్లీట్ చేసేస్తాం. నెక్స్ట్ ఇంకా నెక్స్ట్ ఎగ్జామ్ copper sulfate. Next another well-known example in the redox reactions is reaction between the hydrogen peroxide and permanganate. So if the reaction takes place in acidic medium, this permanganate will be reduced to Mn2 plus. H2O2 will be oxidized to the water and oxygen. So in all redox reactions, the valence factor of hydrogen peroxide, valence factor of H2O2 is always 2. Since the reaction is taking place in acidic medium, valence factor of MnO4 minus is 5. Therefore, equivalence of H2O2 is equal to equivalence of MnO4 minus. In place of equivalence, we can use any formula for H2O2 as well as any formula for MnO4 minus. Next, another well-known example is bleaching powder. When bleaching powder participates in any reaction, it will be converted into calcium chloride and it will supply the nascent oxygen. So here one molecule of the bleaching powder will always supply one nascent oxygen. In this change, what is the valence factor of the bleaching powder? See here, before participation in the reaction, this is a bleaching powder, OCl minus, this one. Here the oxidation state of the chlorine is -1. Here oxidation state of this OCl minus is minus, but therefore oxidation state of the chlorine is +1 here. Oxidation state of the oxygen is -2. Therefore, when bleaching powder participates in the reaction, this oxygen is coming out. It is coming out of the molecule by keeping its extra 2 electrons within the molecule. That means here totally 2 electrons are being exchanged. Therefore, valence factor of bleaching powder is again 2. So when the bleaching powder is used in any reaction, use the valence factor 2 for simplifications. Okay, sir, we'll continue. ఇంకా ఏం పెండింగ్ ఉందో తర్వాత నేను చేస్తాను.